So let's consider an application of this projectile motion. So let's think about a football player. Okay. So let's say that maybe this fall, they're playing NFL, and they don't cancel because of the virus. And so the Cowboys quarterback throws the ball. So we have Prescott here. He throws the ball, and the ball leaves his hand at 31.2 feet per second and leaves his hand at an angle of 25.0 degrees. And let's say that the receiver misses the ball, and so I want to know how far does this go? Okay. And so this is the question, how far X does it go? Now, in our previous example, we talked about maximum range. Could we figure out the range of this? Because if you know that the distance here, the range equation, okay, that we had before was that X is going to be equal to X is going to be equal to V naught squared times sine 2 theta over G. So, could we use this equation to find X? And the answer is no, we cannot. Wait a minute. That was the equation we just came up with for range last time. So, why does that not apply? Well, I want to point out why it doesn't apply, because this is going to be critical, because you're probably going to have projectile motion. Projectile motion is like a big part of the chapter, so expect a projectile motion problem on the test. So why can you not use that equation in this case? And the reason is this was derived for a special case in which the final height equals the initial height. Well, in this case, the ball is not leaving at the height of the ground. So we're going to assume that the initial height is 3.5 feet. Okay, so that means the initial height is not equal to the final. So in this case, the range equation does not hold. The range equation will never hold if the final height is not equal to the initial height. It only works for that special case. So we got to do this a long way. So we know that ball leaves the quarterback's hand here. We know that Y naught is 6.35 feet. We know that the initial velocity V naught and the angle. So we know that Vx naught is going to be V naught cosine theta. And so that's going to be equal to 31.2 feet per second times cosine of 25 degrees. So that turns out to be 28.3 feet per second. We know that Vx naught, or Vy naught rather, okay, is going to be equal to V naught times sine theta. So that's going to be equal to 31.2 feet per second times sine 25 degrees. So that's going to be 13.2 feet per second. So we now know the X and Y naughts. We know that the X distance, X equals X naught plus Vx naught t plus 1/2 AX t squared. We know that Y equals Y naught plus Vy naught t plus 1/2 AY t squared. Okay, well, ball leaves here, some initial Y naught, goes like this. We know that gravity is that way. That's the only acceleration. There is no X acceleration. So AY is going to equal minus G. Okay. If I put my origin right here, because the final height is going to be 0, I can put the origin here and have the final height negative. Okay, or I can put the origin here and have the final height 0. So I'm going to put the origin there, so Y naught is going to be 6.35 feet, and X naught is going to be 0. And so our equations now are going to look like x equals vx naught t, okay, and the other equation is going to look like y equals y naught plus vy naught t minus 1/2 gt squared. Okay, now to find the distance, I need that equation up here. So this is my distance equation. I know this. Okay, so again, it's sometimes helpful to say, what do you know? I know this, I know that, I know that, I know that. Okay, now we have two equations, three unknowns, x, t, and y. But we know it hits the ground when y equals 0. So that means we know this. So that means we can solve for t in the y equation and then plug into the x equation. So it hits the ground when y equals 0. So that means that this is a quadratic equation. So as a quadratic equation, I'm going to rewrite it 1/2 gt squared minus vy naught t minus y naught equals 0. And so that means that t equals vy naught plus or minus vy naught squared plus 2g y naught divided by g. Now, v's are in, we know the v, so this is going to be 13.2 feet per second plus or minus the square root of 13.2 feet per second squared plus 2 times g. If you put 9.81 meter per second squared times 6.35 feet. Oh, wait, we have a problem. Because the numerator, feet per second squared is feet squared per second squared. Meter per second squared times feet is meter feet per second squared. When you add feet per second squared plus meter feet per second squared, it doesn't work. So that means you cannot use 9.81 as g. You must use 32.2 feet per second squared. Now we have feet per second squared, feet squared per second squared plus feet squared per second squared. Take the square root, that's going to be feet per second plus feet per second is feet per second, divide by feet per second squared, and the answer comes out in seconds. So we get 2 times. The 2 times are 1.16 seconds or minus 0.34 seconds. Well, we know it's got to be the positive number here, 1.16 seconds. So x, which is vx naught times t, that's going to be equal to 28.3 feet per second times 1.16 seconds. So x comes out to be 32.8 feet, just shy of 11 yards. So, presumably, if the receiver had managed to make a diving catch for it, then that would have been a first down. But given that it's the Cowboys, maybe not. So this is an example of projectile motion in football.